Hey y'all. Today we're going to be solving absolute value equations, and then at the end of the lesson we'll get into some absolute value inequalities, and I'll show you how to graph those in Desmos and get your answer. Now, these equations are no different than any other equation we've ever solved. You're trying to get the variable by itself. So if it's positive, you're going to subtract. If you're multiplying, you're going to divide, etc., and so on. So you want to make sure you get the absolute value part of the equation by itself first, and then there's one additional step. But other than that, you're solving a regular equation. So for number one, I already have the absolute value on one side of the equal sign by itself. So when you're solving an absolute value equation, you set up two different equations. One equation is equal to the positive of this number, and then the other equation is equal to the negative of that number. So this is y plus 5 equals positive 8, and y plus 5 equals negative 8. So if I reflect back to our video from yesterday when we were doing functions, it's a piecewise function. So we have the left-hand side that was in the negative section, and then a right-hand side that was in the positive section. So we're going to be getting two different answers, so which is why we set up two different equations. So one is equal to the positive of this, and then one is equal to the negative of the number. Then from here, we go through and solve the equation. Subtract 5 from both sides here. And on this side, subtract 5 from here. And voila. Those are our two answers. So subtract 5 from both sides, you'll get your two answers. So y is equal to 3 and y is equal to negative 13. All right, let's take a look at number 2. The absolute value of 10 minus 3z is equal to 9. Again, make sure the absolute value is on one side of the equal sign by itself, which this one already is. So we set up two different equations. So it's going to be 10 minus 3z equals positive 9. And 10 minus 3z equals negative 9. So we set up our two different equations. And then we go through and solve. So we need to subtract 10 from both sides, because the opposite of a positive is to subtract 10 from both sides. Then from here, the opposite of multiplying, we're going to divide. So I got 1/3 for that one. Again, I didn't show my steps there. I just kind of did some stuff in my head. Subtract 10 from both sides, divide by negative 3, because we're just solving a regular equation. I'm going to do the same thing on the other side. Subtract 10 from both sides. And then divide. And it's okay to get fractions. 19/3. So our two answers for this problem are 1/3 and 19/3. All right, next, number 3. So this is what I was saying as far as making sure you get the absolute value on one side by itself. So before I set up two different equations, I need to get rid of the 2. So this is 2 times this. So we're going to divide both sides by 2. So I'm going to divide the left-hand side by 2, and I'm going to divide the right-hand side by 2 so that these 2's cancel out. So now we're left with the absolute value of 3n minus 2 is equal to 12. From here, we go through and we set up our two different equations like we did for problem number 1 and like we did for problem number 2. So 3n minus 2 is equal to 12, and 3n minus 2 is equal to negative 12. Okay, I'm going to do some steps in our head, but if you need to actually write those out, there is nothing wrong with that. I'm going to add 2 to both sides. So I added 2, and I'm going to divide by 3. So one of my answers is 14/3. Do the same thing on the other side. I'm going to add 2 to both sides. And then I'm going to divide. And these are our answers. So I added 2 to both sides, divided by 3, added 2 to both sides, divided by 3. And last but not least, number 4. So again, I need to get this absolute value on one side by itself. So I need to do several things with this problem. We need to first add 12 to both sides. Then we need to divide by 3 and then set up two different equations. So it's going to be a few more steps in there, but we still can go through and do it. So I'm going to add 12 to both sides. So that's going to give me 3 times 3t minus 2 is equal to 18 because I added 12 to both sides. Now I'm going to divide by 3. So divide by 3, divide by 3. So 3t minus 2 is equal to 6. Now that you have the absolute value on one side by itself, this is when you go through and you set up your two different equations. So let me make sure you know that this is, okay, so I try to make it a little darker there so that you wouldn't think that's a number. So this is the absolute value of 3t minus 2. So we're going to have 3t minus 2 equals positive 6. And 3t minus 2 equals negative 6. So we set up two different equations. Add 2, and divide. Same thing on the other side. Add 2, and then divide. And we get negative 4 thirds. So those are our answers, 8 thirds and negative 4 thirds. All right, I'm going to do one more absolute value, just solving the equation, and we'll talk about that one. And then I'm going to show you how to do some stuff in Desmos in case you happen to run across the absolute value inequality. So they are a little different than the equations. So this is an equation. You take whatever the problem is equal to. You set it equal to the positive and the negative, but make sure your absolute value is on one side of the equal sign before you set up your two different problems. All right, let's do one more. All right, so let's take a look here. So I need to get the absolute value on one side of the equal sign first. So we need to subtract 5 from both sides. So that's going to give me 6 minus 4t is equal to negative 5. Now, hopefully this one looks a little different to you, and let me darken my absolute value so that you know that that is just the notation. So the absolute value of 6 minus 4t is equal to negative 5. Absolute value is the distance from 0 on a number line. This is already equal to a negative number. So the answer to this is going to be no solution. So we can't have something that's equal, we can't have an absolute value that's equal to a negative number. So this one is no solution. Right. So be careful when you are solving these. If the first 4 problems that we did on the front side of the paper, if I flip back there, they were all equal to positive. So positive 6, positive, positive, positive. This one was equal to something that's negative. So that is no solution because absolute value is the distance from 0 on a number line. Now, let me get into inequalities and show you how you can get your solution on Desmos. So say we ran across the absolute value of n is less than 5 and the absolute value of 3x is greater than 18. First, let's type it into Desmos. So let me pull up a Desmos tab for us so that we can investigate. All right, so I'm going to type in, instead of n, I'm going to use x. So instead of n, I am going to use x. So let me type in the absolute value of x is less than 5. Okay. Notice this is what pops up. When you have an absolute value that's less than something, your solution is going to be a shaded region in between two values. So let me write that down. So solution is the shaded region in between two values. So what I mean by that is if I look at the graph, I see that my graph goes from negative 5 to positive 5. So your solution is going to be this shaded region from negative 5 to positive 5. So I can write that in inequality form. Negative 5 is less than x, which is less than 5. So when you're doing absolute value that is less than something, your solution is going to be between two values. You'll start with a number, x will be in the middle, and then you'll have some other number. Just a small minor thing. I started this problem with n, so technically this variable here should be an n, but that's just a little minor thing. But your solution is going to be the shaded region between two values. So that is how you're going to handle absolute value that's less than something. So graph it, see what two numbers it ranges between, and set it up as a compound inequality. And the last one, let's see what happens if I have an absolute value that is greater than something. So we'll type it in. 3x is greater than 18. Now, for something that is greater than, your solution is going to be the shaded region on the outside of two values. So solution is the shaded region on the outside of two values. Outside, in between. All right, there we go. So the absolute value of 3x is greater than 18. Our solution is going to be the shaded region in the pink that I see over here in Desmos. So my shaded region is going to be anything to the left over here and anything to the right over here. So let's see what those numbers are. So this number here is -6. I know that because this is -5, so this must be -6. So I need to quantify all numbers that are less than -6. So -6, -7, -8, etc., and so on. So all of those numbers can be quantified by us saying x is less than -6. So any number that is less than -6 is going to be part of my solution. If I come over here to this side, how do I say all numbers bigger than 6? So 7, 8, 9, 10, 11, 12. How do I quantify that? That is going to be x is greater than +6. And you're going to put an or in the middle because all of that is our solution. So anything less than -6, that will be the left-hand side, my shaded pink region here, or anything greater than 6, that's going to be my positive section displayed here. So all of this is our answer. So absolute value equations are going to give you two distinct numbers, two distinct points. If it's less than, your region is going to be shaded between something. And if it's greater than, it's going to be on the outside of two values. And you will set it up as an or inequality.